Hello everybody and welcome to example 3 on page 38 of the workbook. And this is an example of a problem that we're actually going to see quite often in the coming weeks of our course. Okay, so very common application of the derivative is finding the equation of a tangent line. So we'll run through this process step by step together here. Let's read the question together. So they're giving us a function that looks like x cubed plus 2x squared minus 7x plus 10. We've got a graph of it sitting over here on the right. And part A, as we just said, is asking us for the equation of the tangent line to f of x at x equals 2. Okay, let's first draw a picture of what they're asking us to find. So the tangent line at 2 would just be the line that's tangent to the curve there. Okay, so if we draw it, that's the line that we're trying to find the equation of. And the question is, what do we need to do in order to find the equation of that line? Okay, well, let me start by asking you a question. So think back to algebra here for a minute. So what pieces of information do you need to find the equation of any line? Okay, well, if you think about it, one really important piece of information would be the slope. We need to know the slope of that line to find its equation. And another piece of information we could use is a point on the line. If we can figure out a slope and a point, we've got enough information to write the equation of the line. Okay, so that's what we need to do. And let's start with the slope. Okay, how do you find the slope of a tangent line? Okay, well, we know from earlier in the course that the derivative is what gives us the slope of a tangent line. So the very first thing that we need to do here is to calculate the derivative of our function. Okay, and that's where the shortcut formulas that we've been talking about come in. Okay, we have a shorter way of taking the derivative of this function, kind of term by term. Let's start with the x cubed. How do you take the derivative of x cubed? Well, that's x raised to a constant power, so we're going to use the power rule. We're going to get 3x to the 3 minus 1, which is 3x squared. Remember how that works? So we bring the power of 3 down and we decrease the power by 1. Okay, we'll get 3x squared. And then the next term is 2x squared. So the 2 in front is just a constant, so we'll pull that to the side. And then if you take the derivative of x squared using the power rule, you're going to get 2x to the first. Okay, there's that bringing the power down and decreasing the power by 1 again. Okay, then we come to minus 7, and we need to take the derivative of x. Okay, x is really x to the first power. Okay, I'm going to remind you of that by writing that 1 in. And so its derivative by the power rule should be 1x to the 0. Okay, and then finally, what would the derivative of the 10 be? That's just going to be 0 because 10 is constant. All right, let's clear a little bit of that clutter away here. And just simplify our derivative a little bit. So we've got 3x squared, we've got a plus 2 times a 2, that's a 4x. And then 1x to the 0 is actually just 1, because x to the 0 is 1, so we're just going to get a minus 7 there. Okay, so there's our formula for the derivative. And to get the slope of our tangent line, we just need to tell the derivative what point we're interested in. In our case, x equals 2 is where we'd like to find the slope. So we're just going to substitute 2 in for all of our x's, and whatever comes out should be the slope of our tangent line. So 3 times 2 squared plus 4 times 2 minus 7, you can double check my arithmetic. You're going to wind up with 13 if you do all of that. Okay, so here's what we know so far. That 13 is the slope of our tangent line. Okay, and beginning of the problem, we made the observation that we need a slope and a point on the line. Okay, so we need to figure out what's a point on our tangent line. Let's go back to the picture over here to the right for a minute. So one thing I notice is that one point on the line occurs right at the place where the line hits the curve. And what are the coordinates of that point? Well, we can kind of see from the picture that the x-coordinate is 2. How would we figure out what the y-coordinate is there? Okay, well, there we can use the fact that that point happens to be on the curve f that we started with. So we can figure out what the y-coordinate is by just substituting 2 into our function. Not the derivative, but the original function back at the beginning of the problem. So if we take 2 and substitute that in, okay, for all of our x's, okay, that's what we're going to get. 2 cubed plus 2 times 2 squared minus 7 times 2 plus 10. If you do the arithmetic there, you're going to get 12. And what that tells us then is that the y-coordinate of that point has to be a 12. Okay, in other words, you substitute in 2, you get out 12, and so 2, 12 is a point that's on our line. Okay. Can we put all this together then to write the equation of the tangent line? Let's see. Well, the equation of just kind of any old line is going to look like y equals mx plus b. That's slope-intercept form. And the m is the slope. That's the number that's sitting up here. So we actually know that m is 13. And so what's left to figure out here is the b. Okay, if we can figure out what b is, we've got a complete equation for our line. How do we do that? Well, we can figure out b by using the fact that we know a point on the line, 2 and 12. Think of that as your x and your y. You can substitute those into the equation of the line and use it to figure out what the b is. So let's do that. We'll substitute in 12 for y and 2 for x. Okay, and let's see. If we do the arithmetic, then we're going to get 12 equals 26 plus b. Subtract the 26 from both sides, and it looks like b is going to be negative 14. All right, last step is just to write down the equation of that line. Okay, we know that it looks like y equals 13x plus b, but we now know what the b value is. We can just substitute that in, and we get y equals 13x plus negative 14. Okay, or just minus 14. Okay, and there's our answer to part A. There's the equation of our tangent line. Okay, so there was a part B to this problem. This is kind of a long problem that we're looking at. Okay, so B would like us to figure out where is the tangent line to y equals f of x horizontal. Okay, well, let me ask you a question here. So what is the slope of a horizontal line? Okay, it's 0. And we might start this problem by just seeing if we can graphically locate those points. So I'm looking back at the picture of f up at the top here. Do you see any places where it looks like we have a horizontal tangent line? Okay, I see a couple of points, one about here and then one here. And what they're asking us for is what are the x values at those two lines? It looks like one of the x values is 1, and the other one is maybe somewhere between -2 and -3. Okay, could we figure out what those x values are exactly? Where are those tangent lines? Okay, well, we can do that by reminding ourselves that a horizontal slope is really a 0 slope. So it's like asking you to take the derivative and set it equal to 0. The logic here is that the derivative represents slope. It's just asking us where is the slope 0. And we have a formula for the derivative. Up here in part A, we got 3x squared plus 4x minus 7. So algebraically, it's like asking you to take that formula for the slope and set it equal to 0. Okay, notice that that's an equation that we can solve for x. And let's see, how could we do that? Well, maybe let's try factoring here. Okay, so to get 3x squared, we need to take 3x times x, and really the only factors of -7 are either, well, -1 and 7 or 7 and -1. And if you experiment with the possibilities, okay, you'll discover that putting a +7 first and a -1 second makes this work out. Okay, and that kind of takes this equation and breaks it into two pieces. So either 3x plus 7 equals 0 or x minus 1 equals 0. And we can solve those two equations separately. So In this first one, if we subtract the 7 from both sides, we get 3x equals negative 7, which is x equals negative 7/3. Okay, that's one place, one solution. And then over here on the right, if we add 1 to both sides, we're just going to get x equals 1. Okay, those are our two answers. If we've done everything right, those should be the places where the tangent line is horizontal. Okay, and if you look back at your graph, that looks plausible. Okay, x equals 1 sure looks like we've got a horizontal tangent line there. And then negative 7/3 is between -2 and -3. There's our other horizontal tangent line. Okay, and I think that we're done.